Hello everyone, and welcome to another video of the Tech Reviews. So today we're going to be looking at something very special. It is the Asus Maximus XIII Hero motherboard, which has a newest Z590 chipset that is supposed to launch at the end of this month. So I've spent over 60 hours dealing with all the bugs, drivers, and doing benchmarks on this board. And actually I have a mixed feeling about Z590 boards. So first, let's start from the unboxing. Okay, let's start by unboxing the Maximus XIII Hero. So the box itself looks identical to the XII Hero. Let's remove the plastic cover, and that reveals the motherboard itself. At a first glance, it actually looks pretty close to the Z490. Now let's remove the motherboard from the box. And then let's take a look at the accessories. Okay, so first we have our menu with the driver CD inside. And then we have our ROG stickers. And next, what looks like a technical guide or technical updates. And a thank you card from ROG. Okay, and then a domestic cat. I'm sorry, the cat is not included. Okay, she just likes boxes. Alright, so let's carefully remove the cat from the box. And then let's keep looking. So here we got a bunch of SATA cables. And a extension cable for the RGB. And ROG keychain. The Asus Q connector for the front panel. And also the Wi-Fi antennas. This is the ARGB cable. And lastly, a graphics card holder. So here's the unboxing of the M12 Hero. Let's open the box, and that reveals the motherboard itself. Pretty neat design and pretty classic ROG color scheme. Let's remove the motherboard and the motherboard tray. Now let's look at the accessories. So here we have the motherboard menu with the driver CD. We have the ROG stickers. For the accessories, we have a ARGB extension cable. We have some SATA cables and more SATA cables and a set of screws for the M.2 drives, as well as the sticker for the fan. Here's the antenna for the Wi-Fi 6 and a ROG keychain. This is the adapter for the ARGB. And some more screws. And this is a little fan for the VRM, which the M13 Hero did not include. And more screws and the Q connectors for the front panel. On the left is our M12 Hero. So it's got 14 plus 2 phases CPU power delivery. It's got 4 memory slots and 1 USB Type-C front connectors with 2 PCI-E X16, 2 PCI-E X1, and 1 X16 physical slots running at PCI-E X4. However, for the M13 Hero on the right, the layout is a little different. So we got 2 of the PCI-E X16 slots, but we only have 1 of the X1 slots, as the M.2 is taking up the rest of the space and the bandwidth. We also got a physical PCI-E X16 slots running at X4, provided by the chipset. And the CPU power delivery and the RAM looks identical to the M12 Hero, but it is actually different. We'll do the circuit analysis later in this video. These two boards does look identical, with a little bit of difference in the back I/O. So here we have our M13 Hero. You got your clear CMOS, BIOS flashback on the 2 USB ports, with one of them being used for USB flashback. You got your HDMI 2.0 output, the antennas for Wi-Fi 6, and you got 2 of the 2.5 GHz LAN powered by Intel, and you got 6 of the USB 3.2 Gen 2 ports, and there are 10 gigabits per second ports powered by the chipset, and you got your 2 USB Type-C Thunderbolt 4 ports, and of course you got your audio. So for the M12 Hero, you got your clear CMOS button, your BIOS flashback button, And then you got your two USB 2.0 ports, with one of them being used for BIOS flashback. You got your HDMI, but it's only supported up to HDMI 1.4b. And you got one of the 5 gig LAN ports powered by a Quantia chip, and one Intel 1 gigabits. You got 4 of the USB 3.1, and you got 3 of the Type A USB 3.2 Gen 2, and 1 Type C. And of course your Wi-Fi antenna and the audio. As for the M.2 support, thanks to the additional DMI bandwidth provided by the Z590 motherboard, our M13 Hero is able to provide 2 of the PCIe 4.0x4 ports that's directly CPU attached, and also 2 of the PCIe 3.0x4 ports that is PCH attached. And for the M12 Hero, all 3 M.2s are PCH attached. And also M13 Hero adds the back cooling plate for all the M.2 slots to better cool the faster PCIe 4.0 drives. The memory power delivery looks identical, as well as the 2 onboard buttons and the debug LED. I've taken out all the screws in the back, and now let's strip down the motherboard. So first, let's remove the cover for the audio. This one is actually completely metal compared to the plastic on the M12 Hero. And next is the chipset heatsink. It also has a thermal pad, just like the last generation. And next is our whole assembly for the VRMs. This is quite heavy and it's 100% metal. There's a PCB for the RS sync and a connector to the motherboard for the RGB. Wow, this is pretty heavy. So next is our M12 Hero. We also start from removing the cover for the audio part, but unlike the M13, this part is completely plastic. And also unlike the 13, the heatsink for the VRM is not unified. There's a plastic cover with a smaller PCB for the RGB, but they do share the same connector. And next is a C-shaped VRM cooler. There is a heatsink running through the cooler, just like the M13. This cooler is also pretty heavy and well built, but it's just not as heavy as the M13. And there's a reason why Asus decided to use a C-shaped cooler. That is because Asus placed the VCC-IO and VCC-SA power delivery on the left side of the motherboard. But for the M13, because Asus have to reserve the place for the first M.2 PCIe 4.0 SSD, we'll talk about that in detail later. So here's a quick comparison between the 2 heatsinks. On the left is our M13 Hero, and on the right is the M12 Hero. For the actual heatsink of the chipset, the Z590 is actually smaller than the Z490 to my surprise. Next, I'll do a very brief circuit analysis for the M12 Hero just to show you what has been improved on the M13 Hero. So for the M12 Hero, it is also using 14+2 phases, and it is without doubler as well. However, for the power stage, Asus is using a TDA21462, which is capable of delivering up to 60 amps. However, on the initial media review samples, these boards were using TDA21490, which is capable of delivering up to 90 amps of power. So shame on you, Asus. And hopefully the same cost down has not happened to M13 Hero. For the controller chip, it is using an Asus rebranded IR35201. So this is only an 8-phase power controller. Just the V-core and the iGPU will use full 8 phases that is capable of controlling. So to solve this problem, Asus actually used a second ASP1405 chip to control the VCC-SA and the VCC-IO. And unlike the M13 Hero that actually puts the VCC-SA next to the V-core, M12 Hero actually placed them both on the left side of the CPU socket. And that's why the heatsink is C-shaped. So for VCC-IO, it is using exactly the same solution as the M13 Hero. But for VCC-SA, it is using 2 of the NCP302045. Each of them is capable of delivering up to 45 amps of power. So 2 of them makes 90 amps, which is the same as the total combined output of the M13 Hero. Again, this is completely overkill for what it does. And here comes the interesting part. So for PCI-E switching, Asus decided to use the ASM 1480 chip, which is only capable of switching PCI-E 3.0 signals. It is not capable of dealing with PCI-E 4.0, at least not at full bandwidth. And that is the reason why, although this board supports PCI-E 4.0 with the newest BIOS, it actually only supports up to X8 instead of X16 on the first PCI-E slot. That's kind of considered cheating to me because technically you're getting the same bandwidth with PCIe 4.0 by 8 and PCIe 3.0 by 16. I mean, yeah, you will probably get lower latencies, but that's not really the point of PCIe 4.0. However, on other Z490 motherboards, like the ones from Geekbench and MSI, most of them were designed with PCIe 4.0 support in mind, and they were actually using PCIe 4.0 capable switching chips. And for the I/O part, it is also a little bit different from the M13 Hero. So it is using an ASM 1074 chip to provide the 4 USB 5 gigabits ports for the rear I/O, and it is using an ASM 1543 chip for the Type-C support. And it is using a Aquantia AQC111C for the 5 gigabit Ethernet. And it is using the same P13EQX16 chip to amplify the 4 USB 3.2 Gen 2 10 gigabits ports. And it is using an Intel i2-19V chip for the gigabit LAN. And it is using an S-Media ASM 1422K chip for the HMI output. This chip only supports to HDMI 1.4b instead of the 2.0 on the M13 Hero. So next is the Z590. Starting from the chipset, so the Z590 is the same size as the Z490, and this should be pin-to-pin compatible. However, with double the DMI bandwidth, it is able to provide 20 PCIe 3.0 lanes instead of 16 on the Z490. This gives us the additional bandwidth needed for extra M.2 PCIe SSD. And also for the USB side, so the Z590 supports 3 of the USB 3.2 Gen 2x2, which is 20 gigabits per second ports natively. On this particular board, Asus utilized one of them as the front USB Type-C connector. Next is the power delivery. So Asus is using a 14+2 phases for the power delivery. However, instead of using a doubler, Asus is actually teaming up 2 groups of the same components for each phases. So it's actually a 7+1 phase. The controller is an ISL 69269. It's a pretty high-end controller, and it supports up to 12 phases of power delivery. So instead of using 2 power controller chips on the Z490, Asus is able to control everything on this motherboard with just one controller. For the MOSFET, Asus is using a TI-95410RRB, a CDR MOS, with 90 amps of power delivery. So that is a serious overkill for a Core i series chip. And we're looking at 14 phases of vCore here, and also 1 phase of VCC system agent, and 2 phases for the VCC iGPU. For the VCC I/O, Asus is using 2 phases of NTMFS 4C10C MOSFETs with the power delivery ability of 46 amps times 2. Next, let's take a look into the rear I/O chips. It is a little bit different from the Z490 motherboard. As for the rear I/O, let's start from the very left. So on the very left is the Intel JHL8540. It is the newest Thunderbolt 4 controller that's capable of delivering a speed of 40 gigs per second. And on the right is the CYPD5225. This is a Type-C power delivery controller and is always used in pair with the Intel Thunderbolt controller. It is able to deliver 5V 3 amps, which is 15 watts of USB power. And next is the new Intel i225. It is a 2.5 gigabit LAN controller. And on the very right is a TI TDP158. It is a HDMI 2.0 conversion chip that is responsible for the HDMI output. It supports HDMI 2.0 instead of the 1.4B on the Z490 motherboard. However, in order to use HDMI 2.0, you have to use 11th generation Rocket Lake processors. It is not going to work with Comet Lake. And for the other half of the rear I/O, we're looking at 3 of the Paracom P13 EQX chip. Those are the USB amplifier chip, and each of them is able to drive 2 of the USB 3.2 10 gigabits ports. So there's 3 of them that amplifies the 6 USB ports on the back. And on the right is another Intel i225 chip that's delivering the second 2.5 gigabits port. And for the VCC-SA, Asus is using a different MOSFET. It is a TI-59880RWJ. Unfortunately, I'm not able to find any public data online, but I assume it is somewhere near a 60 amps or 75 amps power delivery. Probably Buildzoid will know better. For the memory power delivery, it is using exactly the same design as the M12H. So it is using an Asus customized ASP1103. There's no public data about it, and all we know is that it is a customized IR controller. And for the MOSFET, it is using the same NTMFS 4C10C that is capable of delivering up to 46 amps of power, which is a complete overkill for DDR4 memories. They don't consume that much power, even at extremely high frequencies. For the PCI-E part, it is using 2 of the P13 EQX16 amplifier, and it is using a P13 DBS PCI-E 4.0 switch. And here we also have a GL852G, that is a USB 2.0 hub that is responsible for the internal USB 2.0 header. And also we have the ProClock 2 chip that's generating very accurate clock and frequency for overclocking. And on the bottom of the motherboard, we have 3 S-Media ASM1480 chips. Those are PCIe 3.0 switching chips. So it is switching between the PCIe lanes and the SATA ports, because the third PCIe lane is sharing the bandwidth with SATA 5 and 6. Apart from the 20 gigabits USB Type-C front panel connector, it is also offering 2 of the internal USB 3.1 Gen 1 5 gigabit ports, and the 2 internal USB 3.1 Gen 2 5 gigabit ports are provided by this S-Media ASM 1074 chip. It's a USB 3.1 chip that's capable of providing up to 4 USB ports. So for all the benchmarks, we will turn on the resize bar, and we will turn on the XMP for the memories. We will enable Asus multi-core enhancement to remove all the power limits of the CPUs. So let's open up CPU-C. Again, we're using the same CPU we used in our last review. And in this review, we'll be focusing more on the difference of the motherboard rather than the CPU. If you want to know more about the 11th generation Rocket Lake CPUs, you can check out my other video up here. Now let's run the CPU-C benchmark. As you can see here, so both motherboards are achieving very similar scores. But let me say that again, there's a lot of things to be expected for 11th generation CPUs. It is getting a higher single core score while being 200 MHz lower in frequency. For Cinebench R15, both motherboards performs about the same, and there's a slight increase in score on Z590 boards. And here our ES11700 is getting a single core score that's very close to the 10700. But keep in mind, our ES11700 is running at 4.2 GHz, while the 10700 is running at 4.4 GHz. In Geekbench 5 CPU test, our 11th generation CPU is about 5% faster on the Z590 motherboard. For the handbrake transcoding test, we're transcoding a 1 minute and 21 second 4K video into 1080p 30 FPS. In this case, both CPUs are performing better on the Z490 than the 590, which could be a problem with the turbo frequency. Next comes the V-Ray benchmark. Again, our 10700 is performing way better here, but keep in mind that the 11700 is engineering sample and it's only running at 3.8 GHz all core boost, while the 10700 is running at 4.6. And that's about 21% in a difference of frequency. And that kind of explains the 23% difference in the score. And please keep this in mind for the other tests as well. Next comes Blender. We're doing BMW GPU, BMW CPU, and Classroom. We're using the iGPU for this test. Again, it continues the trend. The 10th gen is working better on the Z490, and the 11th gen is working better on the Z590. But once again, the difference is negligible and within the margin of error. For Y cruncher, we're calculating 1 billion digits of pi. And here's the time it takes. It's almost the same for both platforms, with the Z590 being slightly faster. By saying slightly, I mean 2%, which is not meaningful in real life. So this is the interesting part. For the Aida 64 memory benchmark, the 11th generation is taking a hit in memory performance on the Z490 motherboard. And there's an outlier here, that for the memory read speed, it is achieving about 48 gigabytes per second on the M13H. However, it's only 31 gigabytes per second on the M12H. So for this motherboard, we have to manually adjust the PCI-E configuration in order to enable the PCI-E bifurcation to use multiple SSDs in one PCI-E X16 slot. So here we're using 3 of the Samsung PM981 SSDs. You might ask why 3? Because for some reason this motherboard only supports up to 3 SSDs on the PCI-E X16 slot. This could be due to a problem with the bifurcation on the Intel Core series CPUs. I will need to find out later. We're putting the 3 drives in RAID 0 mode, and we're achieving over 10 gigabytes per second. That's gigabyte, not gigabits. And the result looks pretty promising. So the higher bandwidth of the PCI-E 4.0 is really providing some benefits for the high performance M.2 storage devices. So this is one of the reasons to consider Z590 if you're using a ton of high performance storage. Although it's the latest BIOS, the Z490 seems to have some serious PCI-E problems working with 11th generation Rocket Lake CPU. Yes, I know it's an engineering sample, however, it's working just fine on Z590, so the CPU is not the problem here. So here I'm doing the same test as what I did on the Z590. I attached 2 of the Samsung PM981 drives to the PCH attached M.2 slots, and there is a problem. So even with 2 ultra-fast PCI-E 4.0 drives in RAID 0, we're getting less than 1 gigabyte per second in both read and write. I've checked all BIOS settings, I reinstalled the operating system, and I reinstalled all the drivers, but the problem wasn't solved. I guess there's something wrong with Asus PCI-E switching algorithm. Hopefully it will be fixed in later BIOS updates. But as for now, I just cannot give you a comparison brought by a new DMI X8 bus instead of X4 on the Z490. Okay, now for the CPU part. Now let's take out our RTX 3080 and see if there's any improvement on the GPU performance. So here's our 3D Mark PCIe bandwidth test. However, the interesting part is, although with the PCIe 4.0 enabled on our M12H motherboard, but we're not seeing any increase in bandwidth. After a lot of research, I figured out that if you enable PCIe 4.0, you can only run it in X8 mode on this particular motherboard. This is due to the design limit on the particular motherboard. I'm not sure about other Z490 motherboards, but from what I researched, that some Z490 motherboards would have better support for PCIe 4.0 than this one. Next, let's run some Geekbench 5 compute benchmarks. So I'm running this with the iGPU. As we can see here, so for the 10700, it is getting a much higher Vulkan score on the Z490 compared to the Z590. As for the 11th generation CPU, and for other scores, they're basically within 1% of difference. For 3D Mark Night Raid, we're running this test with the integrated iGPU. I actually noticed a trend here that the 10th generation tend to run better on the Z490 and the 11th generation tend to run better on Z590. However, by saying better, we're talking about 1 to 2% of increase. So that's really not that big of a difference. For 3D Mark Time Spy, again, the score is identical on the Z490 and the 590. However, the CPU score is pretty close for both the 10th gen and the 11th gen CPU, given the 20% difference in frequency. So I guess that translates to about 20% increase in IPC, and that is close to what Intel claimed. For Unigine Superposition, things are quite interesting here. So our 11th generation CPU is achieving a much higher score in FPS, although running at a much lower speed. So at first I thought it might be a mistake in the benchmark. So I run a benchmark 3 times on both the M13H and the M12H. However, I'm getting very similar results. I suspect the only reason would be that it's utilizing some of the new instruction sets supported by Rocket League. For Unigine Vally, there's nothing much to be talked about. However, I do notice that the 11700 is running slightly higher FPS than the 10700. That is remarkable given it's running at a much lower clock speed. So we can expect a decent IPC and FPS improvement for the 11th generation Rocket League CPUs. In Shadow of the Tomb Raider, however, both the 10th generation and the 11th generation CPU is taking a big hit on the M12 Hero. So since the 10th generation does not support PCI-E Gen 4, so this difference is not related to the PCI-E bandwidth. So the only thing I can think of is the resizable memory bar. I guess the Z590 would have a better support for the resizable memory, or simply Z490 needs more tweaks in the BIOS. In Civilization 5, again, the score is a tie between the Z490 and the Z590. However, just like the 3D Mark Night Raid, the 10th generation tend to perform better on the Z490, and the 11th gen tend to perform better on the Z590. Things are quite differently in Hitman 2. Our M13 Hero is actually achieving a marginally better performance than the M12 Hero. This could be due to the more bandwidth PCIe 4.0 is providing. However, our 11th generation CPU is having problem running on Z490 boards, as it's achieving a lower score than expected. For Horizon, things are similar to our Hitman 2. So for the 10th generation CPU, it's actually running better on Z490 boards, but as for the 11th generation, it's achieving about 10% higher scores on the Z590 board. So here are the few reasons why you should buy a Z590 motherboard. So first of all, it's got better support for the 11th generation Rocket League CPUs. And it's got PCIe 4.0 native support, because your mileage can vary if you plan to use PCIe 4.0 devices on Z490 motherboards, just like the problem I'm having here with the Asus Maximus XII Hero. It's got higher PCH to CPU communication bandwidth thanks to the new and improved DMI/8 bus, and it's got native Thunderbolt 4 support, which to me doesn't make much sense, because Thunderbolt 4 is really designed more for mobile devices, like laptops. The lower end desktop boards will not support it anyways, and if you're using a high-end board like an ROG or an Aorus, why would you put your GPU in an external enclosure instead of putting that inside your computer? And unless you're using like 4 or 8 M.2 devices in an external enclosure in RAID mode, I don't see why you need the extra bandwidth for Thunderbolt 4. And if you talk about display output capabilities, again, very few desktop users actually connect to their monitor through the USB-C port. Not to say for the same performing monitor, you have to spend anywhere from $50 to $200 more just for the additional of USB Type-C port, so that you can charge, transmit data, and display signals at the same time. It just doesn't make sense to use that with a fixed desktop. And lastly, it's got native USB 3.2 Gen 2x2 20 gigabits support. That might be meaningful if you're using an external 10 gigabits Ethernet or if you're using a high-performance M.2 external drive enclosure. And next, the reasons not to buy a Z490. First of all, as you can see in our benchmarks, they perform the same on Z490 and Z590. All the difference is mostly within the margin of error. And not everyone would need PCI-E 4.0. Storage is an overkill for most users right now running regular daily works. As many YouTubers has tried, most users will not notice the difference between a SATA and a PCIe SSD. So not everyone would pay the extra premium for PCIe 4.0 SSDs right now. And for the graphics card, further testings need to be done to prove that it would actually benefit from PCIe 4.0. But right now, I seriously doubt it. And thirdly, those boards are much more expensive. Like in our case, you can see in the circuit analysis, for the M13 Hero, just the DR MOSFETs will cost close to $100, which is more expensive than a lot of low-end Z490 motherboards. And as the leaked MSRPs, the Z590 motherboard has about 20% price increase over its predecessors. So that's something you need to consider. Especially, Alder Lake is coming in 6 months with much better IPC and a big little design. So you might want to save your money for that if you're upgrading from a Z490. That's it for today's video. If you liked the video, please hit the like button and subscribe. I've spent over 60 hours in doing this review. So if you like it, please share it with your friends so that I can get more subs and views. Thanks for watching.